Okay, I'm looking at that problem number 15 that we were looking in class, and we're going to go through these answer choices and show which one is false. Okay, so if I'm looking at the first one here, I have the limit as x approaches 1 of f of x is equal to 0, and if I'm going from the left and from the right, this seems to work, so that statement is true. Okay, the limit as x approaches 2 of g of x does not exist. That is also true. Okay, so looking at D, let's take a look at that one real quick, because that one is going to get me something interesting here. So I have the limit as x is approaching 1 of f of x plus 1. So as x is approaching 1, x plus 1 is approaching 2, which gives me f of 2, right? And if I have the limit as g is approaching 1, that's right here. So that's going to be g of 1, which is going to give me f of 2 times g of 1, which looks like it's going to be negative 1 times 1, which is negative 1. That limit exists. This one's true. So the only one that is suspect for us is C, where it's telling me that the limit does not exist. Okay, so clearly f of x is, as x is approaching 1, right? F of x is approaching 0. So that's clearly 0. Now the question is what do I get if I take the limit as x approaches 1 of g of x plus 1? Okay, so this is where this gets interesting. If I had x approaching 2 of g of x, then I would clearly say that the limit does not exist. That's what part B here says, right? But that's not what I have here. What I have here is I have g and I have x approaching 1. And what I have here is that as x is approaching 1, g, for better or for worse, is continuous. Okay? So x is approaching 1, g is continuous. So this means that g times the limit as x approaches, g of the limit of x, this is going to be equal to g of the limit as x approaches 1. Now, as g is approaching 2, g is not continuous, right? But as g is approaching 1, it definitely is. Okay, so now I take this limit as x approaches 1 of x plus 1. That clearly comes out as g of 2. G of 2 definitely has a value here. The value of g of 2 is, in fact, 1. So this is going to give me that this limit is 0 times 1, or in other words, 0. This limit does exist, which makes number C false, which is the one we're looking for. All right, so let me kind of clear some space here and walk that through one more time. All right. All right, so we've got a clean slate. Let's look at that problem one more time so we understand what's going on here. F is never at issue. As x is approaching 1, f is definitely approaching 0. So the first part of that product is going to be 0. Now the question is as x is approaching 1, what's going on with g? As x is approaching 1, g is continuous, okay? Now, the question is near that value, do I have continuity? If I have that, I can swap the g with the limit. The limit as x approaches 1 of x plus 1. If I take the limit as x approaches 1 of x plus 1, I get g of 2. G of 2 is a functional value, which is clearly 1. And 0 times 1 is clearly 0, which means that the limit does exist, which means that this is false. All right, so there you have it. I'm going to ship this to you so you can see it. Thank you for your patience.